All right, in this video, obviously, we're going to be talking about the triangle proportionality theorem. And it states that if a line is parallel, right? If a line is parallel to one side of a triangle and intersects the other two sides, they're talking about segment DE, right? That's parallel to segment AC, and it intersects these sides right at these 2 points. So if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides. So it's going to divide this side into segments that are proportional in length. So these two sides are going to get divided, and those little pieces are going to be proportional in length. And so what you want to do is press pause and get this information into your notes. But what we're saying right here is that if DE, right, if this DE is parallel to AC, remember this means parallel, then, all right, if these are parallel, then BD, this piece right here, is in proportion to DA, same as BE is in proportion to EC. And then, of course, we have the converse, right? That's basically the opposite direction, and it's going to say the same thing, but sort of in a reverse fashion. Okay, and what I mean is, if we start with the proportion statement, then that implies that the lines are parallel. Up here, we start with the lines are parallel, which infers that the sides are in proportion. So either way, we have this nice little proportion or proportionality going on. Let's see how this works in reality. So I'm going to leave my notes up and I'm going to start working on this problem, but all of this stuff right here is what helps me answer, right? If I understand this, how I answer this first question. So what do I know? I know that 12 is to 14 as 15 is to x if these two lines are parallel, and they are parallel because that's what the extra arrows say. So 12 is to 14 as 15 is to x. Cross multiply, I'm going to get 12x equals 14 times 15, which happens to be 210. Divide by 12, divide by 12, x equals, and I get 17.5. That's it. Now, I'm not going to do this on every one, but just to say, well, what if I had set it up a different way? You know, what if you had started with x's to 15? Well, if you're going to go from here to the 15, then you're going to have to go from the 14 to the 12. So 14 is to 12. And when you cross multiply, you're going to get 12x equals still 210. Divide by 12 on both sides, and you're still going to get that x is 17.5. Okay, you complete number 2 on your own. And just so you know, it works out nicely. No decimals. As we move into 3 and 4, what do we notice? I notice that they give me the overall length. So to get this length right here is simply just going to be 55 minus 45, which is equal to 10. So that's 10. So now I have a nice little proportion to set up. I'm going to say x is to 36 as 10 is to 45. Or I could have said 36 is to x as 45 is to 10. Either way, you'll notice I have a 10 times 36 is equal to 45x. So 45x is equal to 360 divided by 45 on both sides. And 360 divided by 45 gets us an x equals 8. And we're done. You can complete number 4. And as you note here, it works out nicely. Don't forget, you got 27 is the whole length. You're going to have to do some subtraction to get this length here. So make sure that you get this actual length right here. This is your key. As we move along, no big deal. I'll work on number 6 for you since it has a little bit more algebra. So we're going to take the x minus 1 and write that in proportion to, or as a ratio with 3x plus 1. So x minus 1 over 3x plus 1 is in proportion to 6 over 21. Now, if you want to keep things a little simplified here, 3 goes into both of these. 3 goes into 6 twice and into 21 7 times. So I'll get 7 times x minus 1 equals 2 times 3x plus 1. I'll distribute. I'll get 7x minus 7 equals 6x plus 2. Subtract 6 from both sides, or 6x rather, from both sides. And I'm going to add 7 to both sides. Do that all at one time. Clean this up nicely. That's going to give me x, cancels out, equals, cancels out, 9, and I'm done. Now, if you didn't do this little simplification, you still would have ended up with the same x equals 9-bit. No big deal. Okay, now you complete number 5, and it works out nicely. Okay, again, don't move on. Complete this first, then move on. These last set of problems, notice it just wants us to determine if Mn is parallel to JL. Where's Mn? Right here. JL's right here. Are these parallel? Right here, right here. Are these parallel? That's the big question. And what if they are? The proportions should work out. What do those proportions look like? 11 to 15 and 10 to 14. 11 to 15.4 rather should be in proportion to 10 over 14. When I multiply 10 times that, I get 154. And when I multiply 11 times 14, what do you get? You should get 154. So check. So the answer to this is yes, Mn is parallel to JL, because that worked out. If it didn't, then they wouldn't be parallel. Can't have one without the other. You complete number 8. I'll do number 9. So first off, we need the length of JM. That's going to be 54 minus 24, which is 30. So this is 30. So we have 30 is to 24 as 37.5 is to 30, or vice versa. 24 is to 30 as 30 is to 37.5. If you're of the opinion to always put the smaller number on the top. Okay, let's cross multiply. Either way, we get 30 times 30, which is 900. And when we multiply 24 times 37.5, we get 900. So check. So yes, right? Yes, Mn is parallel to JL. Now, when you do number 8, if you get a yes, then write a little statement like this and reference your work, or simply say, no, they're not parallel. Of course, referencing your work. And you probably, if it's a no, you'll end up with, I don't know, something like, 87 doesn't equal 90 or something like that. I'm not saying that that's what's the multiples up there. I'm just giving an example. So you complete number 8 on your own. The next section of notes isn't overwhelmingly mind-blowing. It's just sort of a continuation or an expansion of the current thought. If 3 or more parallel lines intersect 2 transversals, then they cut the transversals proportionately. So just think about this as, sort of what was happening with the triangles. You have 1, 2, 3 parallel lines intersecting 1, 2 transversals, which means that this space and this space is proportional to this space and this space. Okay? No big deal. Don't make high mass of this. So again, if you have line AB right here, parallel to line CD right here, parallel to line EF, everybody here is parallel. If these 3 pieces are parallel, then you're going to have some nice proportions happening. And that proportionality statement is going to be AC is to CE, AC is to CE, the same as BD is to DF, right? We got that little color coding proportionality. All right, so let's put this into action. And we have 10 and 11 right here. So no big deal. We see that we have these 3 parallel lines cutting these 2 transversals. So x is to 52 as 18 is to 45, or 45 is to 18 as 52 is to x. It doesn't really matter how you set it up. Again, my setups follow my little colored arrows. So if you look at the blue, I said x to 52, so 18 to 45. But notice when you are consistent, you get the same exact cross multipliers. Okay, so now all that's left to do is to finish that cross multiplication. So we'll get 45x equals 18 times 52, which happens to be 936. And when we divide that by 45, we get 20.8 as an answer. So no big deal that that's a decimal. Okay, now you know what's coming. You complete number 11. Okay, press pause, then move on, right? Do this one first, then move on. I will tell you that it works out nicely. Okay, this one works out nicely. Okay, so 12 and 13 both work out nicely. So I'm just going to grab number 13, but they both have this situation where 92 is the full length or 32 is the full length. I need to know what this little piece is right here. So that's going to be 92 minus 28, and 92 minus 28 is 64. So this is 64. All right, so let's work our way from bottom to top. X is to that as 64 is to 28. So it's going to say X is to 31.5. Same as 64 is to 28. Okay. Now, seeing that 28 is the smaller number in that ratio, then I'm going to surmise that 31 is the smaller number in this ratio. Okay. And after we cross multiply, we end up with 28x is equal to 31.5 times 64 is going to yield us 2016 or 2016. Divide by 28, divide by 28, x equals, and we get 72. All right, so this is pretty good. And now this one's all yours. Okay, do this one now, and it works out nicely. Okay, this one works out nicely. Press pause and then move on when you're ready. Last two here, both work out nicely. I'm going to leave you for 15. So this one's yours. All right, left you the one with the double algebra statement in here. And I'm going to take number 14. And again, just a nice, easy setup. We're going to go from 18 up to 24 and 12 up to this way, right? Just stay consistent. That's the biggest piece here. So we're going to say 18 is to 24 as 12 is to 3x plus 1. Okay, and we're going to cross multiply there. So that's going to be, well, I guess before we cross multiply, how about we take 18 and 24? Those are both divisible by 6. Let's reduce that to make our world easier. 6 goes into 18 3 times, and 6 goes into 24 4 times. Yeah, it's much easier. Now we can do the math in our head. As we cross multiply, we're going to get 4 times 12, which is 48, and 3 times 3x plus 1 in parentheses. That's going to be 48 equals 9x plus 3. Subtract the 3, subtract the 3, and we get 45 equals 9x. How nice that is. X equals 5, and we're done. This is yours, and just one last, it works out nicely, note for you. You're all set. When you're done with the notes, check in with me. Take care.